this is actually delivering something that we have been really, really wanting in Western Australia for a long time. Complete management of the total water cycle on site by a village. So I'm very, very excited about this presentation because it's not just in the planning stages, it's actually being delivered at the moment. So it's very fabulous that that's actually happening. So we have a few people online at the moment. So if anybody wants to pop their name into the chat, say hi, let us know which country you're on. That would be lovely. There's a few people there. We'll say hi, Krish. Surely, Krish, you're going to turn your video on and say hi. Just thinking about it. All right. Well, we might get started anyway, because I know Wayne's got some fabulous slides to share with everybody. So for those of you who, admit. There we go. Okay, so for those of you who don't know me, my name is Shelley Shepherd. I am the Program Manager of New Waterways, and New Waterways is the capacity building program for water sensitive urban design in Western Australia. We have some fabulous partners who are part of our board, and they are the Department of Planning, Lands and Heritage, the Department of Water and Environmental Regulation, the Department of Biodiversity, Conservation and Attractions, the West Australian Local Government Association, the Urban Development Institute of Australia, and the Water Corporation. And I'm very excited by that group of people who get together to try and work out, well, what is the best way for, what capacity needs do we have at the moment to help us deliver water sensitive urban design, and this is absolutely one of them. So the first thing I'd also like to do is acknowledge the Whadjuk Noongar people as the traditional custodians of the land on which I am sitting, and pay my respects to elders past and present, but also acknowledge the Whadjuk Wadandi people, the Noongar Wadandi people, which is Wayne's country as I understand, and recognise the incredible strength and beauty of their continuing culture, which has been going for so incredibly long, and we are very, very lucky that we have a part of it. We've got someone. Yay. Hi, Griff. How are you going? That's lovely. So if anybody wants to pop their camera on, just say hi at the moment. Please feel free to pop your name into the chat and say hi, because I know I think we're very, very lucky here in Western Australia because we can get together, but I know people all around the country are still struggling and still in lockdown, and it's hard for people to connect again. But anyway, we'll keep going. So my intros, I think I've got there, but I'll let you know. This webinar is about the Witchcliffe Ecovillage, and it's going to provide an overview of the Ecovillage that is being developed just south of Margaret River in West Australia's southwest. The Witchcliffe Ecovillage is a village-scale settlement that demonstrates a new model for sustainable residential development, embracing 21st century technology combined with traditional village values that strongly support community development. This presentation is going to provide insights into designing the fully integrated village that generates its own power, it grows its own food, it promotes local building materials and creates job opportunities for its residents, but most excitingly manages its water, wastewater and drainage systems on site. But I'd also like to introduce to you our presenter. Wayne Pragnell is the engineer for Witchcliffe Ecovillage from its early planning days in 2015 to 2021, when the first phase of construction was completed, which is so exciting. This included a multitude of challenges to conventional planning and design to support new approaches to land tenure, landscape design, energy, and the transport network, and of course, enabling the new residential community to manage its entire water cycle on site. Prior to working at the Witchcliffe Ecovillage, Wayne had roles including engineering director at the Shire of Augusta-Margaret River and city engineer at Bunbury. He has successfully built and raced electric cars in electrothons and is the Southwest chair of the WA Rare Fruit Club and enjoys growing fruit that you've never heard of. I think that's awesome. So please welcome Wayne. I'll hand over to you now, Wayne.
Thanks, Shelley, and thanks for that great introduction. And it's great to be here and talking about the development that we're actually doing. For so many years, I've been saying this is what we're going to be doing. Now we can say this is what's happening. So it's fantastic. I just want to start off by talking about why we should build a sustainable community. And we all know that humans are having an increasing impact on our planet, on our country, and more often than not, our local environment. And I just want to refer to the concept of ecological footprints as a really good way of quantifying those impacts. They measure our impact by calculating the effective area of land for everything we consume: our food, our energy, our water, our transport, our industry, our leisure. It can all be calculated to work out what our combined footprint is, and this can be balanced against our available productive land area. The Worldwide Fund for Nature estimates globally our footprint is about 1.6 times the capacity of the Earth. But locally, when you look at the Aussie lifestyle, we're a lot worse. We use about 4 times more than the global average. And so if everybody lived like Aussies, we'd need 6 planets to for the resources so we could live like Australians. So it really is important that we start finding a better way of designing our settlements to live more sustainably. The largest component of our ecological footprint is carbon emissions, and they're a cumulative issue. They last 300 to 1,000 years in our atmosphere. So it means the decisions we're making now have a very long-term effect, which is why it's a fairly urgent issue and a multi-generational issue. The decisions we're making are going to affect many generations into the future. And I think a lot of us work in the development industry, and by designing and building more sustainable communities, we can have a very significant positive impact, not just now, but well into the future for many decades to come. So we'll go over just a little bit about the background of the Witchcliffe Ecovillage story before we get right into the water sort of side. And we saw in the early 2000s, long-term planning for the Capes region took a bit of a leap with the introduction of the Lewin Naturalist Ridge Statement of Planning Policy. And the policy wanted to, one of the outcomes was to look at trying to take some of the growth pressure off the major centres of Margaret River and Dunsborough, and look at having more development in some of the smaller settlements. And Witchcliffe was one of those. At the time, it had around 50 people, and the planning was to grow to sort of 1,500, 2,000 people. And the council supported that development, but it wanted to use this opportunity of virtually a new village from scratch to showcase a more sustainable form of development. At the time, I guess the Shire sort of controlled more the water and transport elements, and the transport was quite difficult because it was sort of controlled through a lot of the state planning processes for roads, and they decided that the most effective thing that they could focus on was water. And they put some pretty strong water vision in their Witchcliffe Village strategy. But then we had the GFC and a demise of one of the key developers, and the landowners that were left were lobbying the Shire to dismantle some of these sustainability issues to allow a quick carve up of the lots. And one of the issues is sewage is difficult in WA, and they really wanted to increase the lot sizes so they could be above the WA country sewage policy threshold to avoid the whole sewage issue. So without the vision and energy of Mike and Michelle Hume, and sorry, I've just we could have, and Mike and Michelle saw Witchcliffe as the ideal location to build an eco-village. And so without Mike and Michelle, Witchcliffe could have just become another rural residential satellite of Margaret River. Mike was working in partnership with the Perrin Group after previous successful developments, and he had the backing of Stan Perrin for a new model sustainable village. Planning commenced around 2010, and more detailed planning, including the scheme amendment, structure planning, subdivision planning, and the design approvals. And myself, I got involved in 2015. And because of the unique nature of the project, we established a local design office in Witchcliffe. And we completed a lot of the planning and project management in-house through Sustainable Settlements, which is Mike and Michelle's company. The Shire have consistently been public supporters of the project, and there's been a lot of community support, but it didn't always translate to easy or fast planning and approval process. And I think it's fair to say there's always been a lot of caution and scepticism from staff and agencies through the process, just because it is a bit different. From a developer's perspective, delivering innovation does add a lot of cost and time. And so if we want bold, innovative projects, we need to be able to work more collaboratively and streamline the approvals process. We need to, if we want to push boundaries, we also need some bold leadership in government. So just to go over the layout of the village, and this is kind of an overall development concept plan, and north is facing up the page, so Bustle Highways on the left, and the existing village town site. You can kind of see. Can you see my arrow? Is in here. So you can see the scale of the village is really significant compared to the existing town size of the existing town site. It's laid out into 11 residential clusters. So each one of these is a cluster, a residential cluster, and it's got a range. You can see by the different colours of the lots, they've got a range of different lot sizes in those clusters, ranging from 250 square metre affordable lots, which is these little strips of bread, 450 plus cottage lots, and 1,000 square metre family lots. And this is an example of a cluster. So each one of these clusters is a strata survey subdivision, and they each surround their own community garden. Each of the lots has an exclusive garden for vegetable growing in the community garden, and they own that community garden as strata common land. If I go back to the village centre, all of the clusters, the residential clusters surround the village centre, and the village centre is in here. And the village centre has the main commercial area with backpackers, tavern, restaurants, and commercial is built around a village green. And then there's also larger commercial, there's tourism, an oval, and aged accommodation, all within close proximity to the village centre. This one here's our food hub, so I'll get onto that a little bit later. Our built form is, this is the village, just a bit of a representation of the village centre, and it's quite exciting that a lot of the landscaping is all in now, and the buildings are not far away from starting. The built form is a key part of achieving our sustainability outcomes, and there's strong controls in place to ensure sustainability, amenity and aesthetic outcomes. I'm not going to go into detail on this because the focus today is water, but I will say that passive solid design principles are enshrined in our design guidelines, and they've been developed using life cycle assessment modelling to make sure we're achieving the most sustainable outcome over the full lifespan of the buildings. Each building is also, as well as us testing our various options to develop our design guidelines with life cycle assessment, each building is also subject to a life cycle assessment to make sure we're achieving the project goals of carbon negative buildings. And they're assessed by the developer before going to the Shire for planning and building approvals. And if you'd like more information on the design guidelines, we want to sort of make a lot of our information and work public to help other people improve their developments. And so those guidelines are available on our website. Some of the buildings taking shape. We've got a really interesting mix of materials. A lot of timber, because timber actually captures and embodies carbon in the building fabric. We've also got rammed earth, we've got hemp buildings, we've got straw bale buildings. So energy, a large part of our national ecological footprint, as I said before, comes from energy use, and it's an obvious area which we need to focus on. Ecovillage. So we've started with the energy efficient building design, but each home also has rooftop solar, and each cluster has a microgrid, and it connects every house in the cluster, and each microgrid has an energy management system, a 232 kilowatt Tesla battery, fast electric car charging, and that battery allows us to have a very high current to enable that supercharging to take place. We have 3-phase to all of our houses, so there's faster vehicle charging at the house, and each cluster has a grid connection, so they've got backup power in the event of issues, but probably more importantly, so we can feed our surplus solar power back into the grid. And by having such a big battery capacity, that feed-in can happen at the best time of the day and really maximise our I guess, the economic benefit to our residents, but also help Western Power. The battery storage really helps them stabilise their grid at the end of a long supply line. And our lighting for pedestrian network also comes off the microgrid. So our village has a strong focus on community. And this is our community centre at the heart in the village centre. And we sort of see the community gardens are a really great facilitator of social interaction and to really encourage the neighbours. Some of the questions I get at previous presentations are people going to take all the food they're growing? But I think in practice, what happens when you have a veggie garden, you actually have a surplus of food, and it actually encourages sharing and a lot of interaction. So we see that the gardening and that is a really important part of community. We've got a community centre, we've got a lot of community events, ideas for community events, and community projects that will bring the community together, such as bush regeneration. We've already got community members getting together in groups to help manage the avocado orchard. And lot purchasers know when they buy in, and it's an attraction that they're going to participate and volunteer in maintaining their community, which is important in creating a strong sense of place. The village has a strong focus on local food production. And when you think about growing food, you also need to think about water. Food's got an enormous water footprint. When we started researching this, it really was kind of much. We were looking at what we're using in our home, but what's in our shopping basket embodies far more water than what we use in our homes. Just one cup of coffee can take 140 litres of water to make. Depending upon where and how your beef is grown, a 200-gram steak can be equivalent to having 50 showers. So we can grow food sustainably in an urban setting by using our excess stormwater from urban runoff to supply the water, and we can use regenerative farming practices and organic principles to minimise our fertiliser inputs. And by eating our food as locally as possible, we can avoid most of the transport energy inputs. So not just is it good and it's healthy, but it's also really good for the environment. This is just to sort of show the range of food that you can grow in our southwest region. This is just a day's harvest from our garden last summer. We've also got a organic vineyard, which was started off by Kate Mantell. It was the original farm. The whole farm was originally started off as a vineyard. We've kept 6 hectares of that, and this is a staff. We had a staff day where we sort of picked grapes and made our own wine, which was a good little exercise. And each household has their own herb and veggie garden, 200 square metres per person, and this is one of our first residents already before the house is built, planting the veggie garden. And the veggie gardens are irrigated from our dams, which I'll talk about later. So every veggie garden has a irrigated, and they're located in the community garden. Just mention transport. So our roads were a bit restricted with the planning rules. We had to follow conventional subdivision practice. Things like fire trucks and rubbish trucks tend to dictate transport. We did keep our roads as narrow as possible and as tight as possible to minimise speeds. within those restrictions. But what our focus has to make the village more suitable for pedestrians is a very high quality path, off-road path experience. We've taken all of our paths off the roads through the village gardens. And there's a maximum distance of about 500 metres from your front door through the community garden to the village centre. We've got recreational trails around the dams through the bush region areas. And we're also planning, I think, for electric vehicles. So we're starting to see electric vehicles being sold in greater numbers. It's interesting to note that in Australia, Tesla Model 3s last month actually exceeded the number of Toyota Camrys being sold. So it is starting to happen, despite some resistance in the market. It really is starting to happen. And so we've got 3-phase to every dwelling, and we've got superchargers for high-speed charging in every cluster. A lot of people ask about the governance, because the governance has been something that is sort of quite challenging. How do you do something different where you've got sort of shared ownership and management of things that perhaps the local government doesn't want to get involved in? So each cluster is a survey strata lot, and the community garden is owned as common property. So the Strata Act provides a structure, a legal structure and framework, and through the bylaws to have management and controls for the community garden, management of the infrastructure, and funding mechanisms to ensure they're sustainable financially into the future. The common village infrastructure, the bigger infrastructure such as dams, bush region areas, which is common to all of the clusters, they're owned, they've been transferred to a not-for-profit company, Ecovillage Commons Limited, and the shareholders of the not-for-profit company are each of the strata, each of the strata companies. So that gives a strong mechanism that the community land will be owned by the community in perpetuity. We've enshrined our goals and our principles within our strata bylaws, so things range from pet ownership, solar access, garden management, and the building design guidelines. They're all they're not actually in the strata bylaws themselves, because there's obviously restrictions of what you can and can't put in, but they're all a lot of those things are, and the building design guidelines are referred to and as part of that. I guess also just to make while we're talking about governance, to sort of make a brief mention of the Wastewater Scheme. So it is a licensed wastewater scheme under the Water Services Act. The land is owned by, on which it sits, is owned by Ecovillage Commons. Other than the roads and things like regular shire roads, and the services are in the standard sort of shire vested roads, but things like the wastewater treatment plant site and some of the pump station sites are in Ecovillage Commons land, and that land is leased to the licensed operator under a long-term peppercorn lease arrangement. And the Water Services Act provides the legal framework for access to the sewage infrastructure, operation of the scheme, and the powers for the operator to collect revenue. And that's the same legislation under which the Water Corporation operates. Okay. So now, so we're pretty unique in that the entire water cycle, from rainfall coming onto the site, provides our potable water, right the way through to treated stormwater being used for our landscaping and our food, and treated wastewater is reused for growing timber and avocados. There's no scheme water supply for potable water, and irrigation water all comes from the rainfall that falls on the site. We're at the top of the catchment, so we're not capturing water from the streams flowing into the site. We're just taking the water that's falling on our site. To meet WA Health Department regulations, each lot must have their own rainwater tank. So with our smaller lots, it would have been nice and probably a bit more economical to have bigger tanks and sharing of tanks, but that really is very difficult to manage, and the regulations would have required, just to have a shared rainwater tank, still would have required a licensed water service provider. So each slot, whether it's 1,000 square metres, 450 or 250, has its own rainwater tank. we've done a lot of research to be able to understand water use in efficient homes. And there was really very little information about water use of properties that are on rainwater tanks in Australia. There's 1 or 2 studies from over east that we use. We spoke to some of the leaders in that sort of area from around Australia, people like Peter Coons and Stuart White, who are looking to really forward knowledge on rainwater tanks. But we've had to really try and work out a lot of things from first principles, but we were fortunate in being able to get some data from the Water Corporation from homes within Margaret River that sort of showed that water consumption patterns across the region vary significantly from that in Perth. And we've also looked at people like Josh Byrne and Michael Mobbs, who've looked very closely at water use within a sustainable home. So we've created a set of guidelines that are a lot more sophisticated and a lot less conservative than the Shires' usual flat requirement of 160 kilolitres minimum storage on a rural property. And we published these as part of a residential water guide, and that's available on our website if anybody wants to have a closer look. So our minimum water consumption that we require is 100 litres per person per day. And but you might want to provide a little bit more than that. And 100 litres per person per day, that equates to about 20 to 30 kilolitres of storage per person, depending upon what roof area is feeding those tanks. And we've got the Bureau of Meteorology weather station that is actually located on our farm, and so we've been able to take about 15 years of sort of half-hour, very fine timescale data and do detailed modelling to sort of see how that performed with real-world data of what had occurred in the past. And there's some tanks going in. The tanks are all on the roadside, so when you drive around, you're really going to see those tanks. And it's really sort of set up so that the pedestrian interface is on the community garden side. So moving on to stormwater. So our stormwater has been designed around open systems as much as possible. So we wanted to mimic natural systems, and we wanted to make stormwater a strong landscape feature. Some of the observations in analysing our stormwater system are that there's inherently, when you move to an open swale system, there's inherently a large vegetated surface area that fulfills our stormwater treatment objectives very easily, and it easily meets Department of Water stormwater treatment requirements. The system's also inherently very resilient because small increases in the depth of the water in a swale provides large increases in flow. And our swales, to sort of satisfy, I guess, our own requirement to make things safe and accessible, and also the Shire's requirements, our stormwater swales typically have batters of 1 in 4 sides. There are some steeper areas just due to topography requirements, but they're generally fairly gentle swales. There's a lot of distributed storage throughout the system, but the flows need to be slowed down to take full advantage of this. Actually, just before I go off that slide, the blue is just like a footprint of all the open swales. So normally you would just see in a residential subdivision, you would just see a few blobs where you have some open basins. You don't see, none of the pipes are highlighted, so all of those blue lines are swales. And there's a sort of a typical example of the swales. The landscaping still being established. You can sort of see we put some rocks in. This one's we're just starting to get those plants in. And this is sort of a more village centre type swale where the level of landscaping is a lot higher. So there's a lot of distributed storage, but the flows need to be slowed down. So how do we slow them down? This is a typical roadside swale. You can sort of see the plants. This is after some heavy rain, so it really highlights how they're working. Stormwater basin, sorry. I just want to go back to this. So what we've done is in order that the water just doesn't flow straight down the swales and increase peak flows at the end of the system, we've put a lot of, I guess you'd say, chokes in the system. So all of the driveways, all of the path crossings give us a really good opportunity to have just some points where we can slow the flow down and hold it. The system works really well with blockages. So because the swales end up as they're an overland flow path, as well as the minor conveyance system, the major system as well. And they're also very effective, probably I think a lot more effective than subsoil drainage controlling groundwater levels. Subsoil drainage is great when you first put it in, but you never really know how well it performs longer term. Whereas a swale, you can always sort of seed them and easily maintain them. So the biggest challenges, I think, are dealing with crossings, in particular driveway crossings. So we've built them up front, and we've built them to a high standard with stone walls, so that they're consistent so provide us a landscaping opportunity. The implementation is there's an example where we've just a little upturned end on the end of the pipe. We looked at all sorts of options to try and slow the water down from little filters on the end of pipes, but at the end of the day, I think simplicity is required to make sure it's going to be to minimise the long-term maintenance and make it resilient. This one is really easy to. The little upturned end helps keep the silt out of the pipe. It helps provide a bit of extra storage in the swale, and it makes it easier to poke a hose down there if it ever needs to be cleaned out. So I had some real issues initially with 150 millimetre pipes, because it's normally there's a minimum culvert size on a road of 300 mils, I think, in most local governments, and we really needed the smaller pipes to achieve that short-term storage. If we put in big pipes, we would have lost those opportunities for keeping water stored effectively throughout the catchment. There's a path crossing. We've got a lot of, we could have done these probably more economically just using a culvert, but we used it as a landscaping opportunity to really highlight the swale and the crossings of the stormwater system. Before I go into this one, I just want to go back to this. Sort of shows we do have a bit of grade in areas across the site. Generally, some parts of the site are quite flat, but some parts there is a bit of topography in some parts, and so to manage the erosion and screens, we put in a series of riffles, and the riffles are also really effective in trapping the sediment and slowing the water flow down, creating little pools in the swales to create habitat. And again, this is not long after some heavy rain. There has been a lot of earthworks was done on the site, so you can see turbidity in the water, and as the vegetation starts to get established, and you won't see any turbidity. This is just sort of, but the system's working. It's dropping all of it out. I guess one thing about the an open swale system, it's not set and forget like a concrete pipe system. It does need a lot more effort to get it established initially, so there does need to be a bit more initial commitment from the developer, and it's not expensive, it's not difficult, but just need to be aware that it takes a season or so to get established, and a bit of management of erosion and sediment while the vegetation gets established. There's also an interesting question of where the system starts and stops and who's responsible. So in a pipe system, the civil works clearly defined. In this case, we also had a minor swale system. These are the ones that I've been taking photos of, are our major swales, but we've also got minor swales just to keep our garden areas drained. They're actually very small, something you could easily dig out and maintain with a shovel or a spade. And there's something that the community will be more involved in maintaining. Whereas the Shire, the main drainage system and the pits and pipes that go through the community gardens will be Shire assets and Shire maintained, but the vegetation will be maintained by the community. And we've got agreements in place with the Shire about how that will all work and operate. An open swale system does take up more space, and we did make our road reserves, we thought, fairly generous. And I guess when you start looking at a lot of other services, and we had irrigation and sewage, we didn't have water supply, but we had NBN, we had power. All of those things need to be fitted in around the swales, and mostly it wasn't a problem, but we did run into a few issues where we found pit lids were challenging to fit in with the swales. So it would have been nice to have maybe another half a metre or a metre in our road verges, just to make it a little bit easier to fit in our swales. And just another thing, just we're wary of or mindful of, is that the hydraulic performance of an open swale is affected by how they're vegetated and how they're managed, and that can change over time. But we think that's more than offset by the fact that the swales are very resilient, have a large capacity, and only takes a small increase in water level to have significant increases in flow. So as well as the water sensitive reasons for designing an open drainage system, I think we need to recognise that people do like to have a connection with water. Our current model for developments and stormwater is to hide our waterways underground in concrete pipes. It's expressed in a few spots in basins, but largely we just bury our waterways. And why is this, when people love to be in contact with rivers, with lakes, with oceans? And so I think if we're prepared to move more to natural systems in our developments, we'll gain some really big advantages in the landscapes and really create a much a richer sense of place. Now, our 3 urban catchments have a large water storage dam. The central dam here that was built by Cape Mantell as part of the vineyard, so we're using that. That's right in the centre of our village. And then we built 2 additional large dams, one to the north, one to the south. This was only just after we built them, this aerial, so they're a lot more established now, and a lot fuller after the current winter. And they have some important functions. They've got an ecological function. There's a huge amount of water birds. There's vegetation around the edge. There's fish and mussels and marron living in them. There's frogs and things all around them. So they're a fantastic habitat value. They preserve the natural stormwater regime downstream. And so any increase in runoff from the urban development is very easily mitigated with a large water storage body. You know, we always put basins and things in our developments to try and slow the water down, but they're never as effective as a large water storage like these. And importantly, for quality of life within the development and for growing food, they allow us to store surplus stormwater economically. We've got around 250 megalitres of water in 3 dams. The original dam, yeah, I sort of said. Yeah, so in WA, we've got wet winters, or particularly in the southwest, we've got wet winters, dry summers. And so we really need to be storing water if we want to have a high quality landscape in our communities. And really there's only 2 cost-effective ways to do that. If you've got an aquifer that sort of suits aquifer storage and recovery, like we do have a lot in Perth, then that's an excellent way to capture, store and reuse our stormwater from our developments. In the southwest, where we've got silty, clayey, rocky soils, we often quite frequently don't have that those aquifers where we can do that. And so really surface water dams in that sort of instance, the only really feasible option. Yes, there are the technical options, but sort of the volume of water that you need for irrigating large landscapes, it's really not it's really cost prohibitive for most options other than a water storage dam. In this case, well, dam ownership is an interesting issue. In this case, we're fortunate that we wanted to keep the dams under control and ownership of Ecovillage Commons. And frankly, the Shire was terrified about owning a dam. At one point, I thought we'd give them a little bit of a dam so they could have access to the water for irrigating their oval, like a legal point of access, and even that terrified them. So the dams sit wholly within Ecovillage Commons, which is, as I mentioned before, is owned by the community, and we provide a water supply to the Shire for streetscapes, for their oval, and for the village centre landscaping. Here's a bit of a, we've now got a causeway across because we'll have a road going across the dam to connect the northern and the southern parts of the community. We've got paths around the dam because there's such a nice landscape feature. People are going to want to walk around them. We've got all of our landscaping in place. We've our pumping systems for our irrigation are, sorry, just to back up, our irrigation goes to every community garden has an irrigation system. All of the, and I think I forgot to mention at the start when I was talking about the layout, around the outside of our residential area, we've got 1 hectare agricultural lots. And so each agricultural lot has a irrigation water supply, our village centre, our oval, and all the community gardens. All of our streets have irrigation, and it all comes from our dams, which capture the stormwater. And our pumping system is primarily solar. So this is one of the largest solar pumping installations in the southwest that Grundfos have provided. And they've got a great new solar solution where they've got an integrated inverter and pump controller. And that pumps water up to our fire tanks and a tank in each of those clusters and on each of those agricultural lots. And here's an example of the tank that's in the cluster. We've also got a similar tank in the village centre for the Shire. So we meter the water coming into the tanks. And then each cluster is then responsible to then pump their own water from their irrigation tank. And that allows a really good way of controlling how much water everybody's got. They can't just pump unlimited water from the dam. They can only pump as much as we've set the tanks to refill. So moving on to sewage. We've established a new water utility under the Water Services Act, which is licensed by the Economic Regulation Authority to operate the village sewage system. There's only a handful of water utilities licensed for sewage around the state other than the Water Corp, and many of them being mining companies for mining villages. So we're one of the few independent water utilities for land development. And unfortunately, there was one at Lancelin, which recently failed due to lack of land sales, not really the fault of the actual scheme itself. It just didn't have the land sales to back it up. And so that was now being taken over by the Water Corporation, I understand. And so it's really important that we make a success of this to prove the feasibility of decentralised sewage systems in Western Australia and to provide an alternative to the Water Corporation model of large centralised sewage systems that have massive pumping costs, huge infrastructure costs, and importantly in the southwest, they present a really large barrier to communities for treated water reuse. They present a really large barrier to getting new developments off the ground. The Water Corporation, we did talk to the Water Corporation for Witchcliffe on a number of occasions. There was some interest at some times of getting involved in an alternative scheme, but at the end of the day, they always went back to their standard solution, which was just to pump all the water from Margaret River and pump all the wastewater back to Margaret River. And the cost of the infrastructure of putting in a pipeline, from Margaret River at Water Corporation rates was, probably 3 times the cost of building a local decentralised plant without any of the advantages of water reuse. Not to mention the energy costs that would have been involved in pumping. So the Ecovillage has 3 sewage catchments, and they follow natural contours across the urban part of the village. Each lot is serviced with a lot connection and a gravity sewer. Our sewers are just standard 150 PVC sewers, just like you would be in a standard water corporation development. The catchments are quite small by Water Corp standards, so the pump stations are quite small, and they pump via a common pressure main to a treatment plant down south of the site. And so this is our treatment plant now under construction. It's a moving bed bioreactor, MBBR plant, and the first MBBR unit is this unit here. And that's basically a tank which is full of plastic pieces, a bit like sort of spaghetti dinosaurs, and air bubbles up through the plastic sort of spaghetti inside the tank. And the reason that it's really efficient in terms of energy, it's got a very large surface area on all that media inside the tank, and that allows the microbes a large surface area to grow on. So the treatment plant's it's built from off-the-shelf components, so technically it's pretty straightforward. It's got automatic screening unit in this building here, and that's really important also in minimising the plant energy usage, because by screening out with an efficient screen a lot of the organic loading, you don't need as much energy in the MBBR units. In this over here, we've got a sludge dewatering and drying system, which is specifically developed for small municipal plants. And then the third building over here is a lab. So our operator, TMC Witchcliffe, is going to set up a lab so that they can, on site, so they can do a lot of their own analytical work. Here we've got storage for inflow, storage for outflow. Other than that, you know, all pretty simple and standard technically, but the biggest challenges have been with the approvals system. So here's another view of the plant. This is a stormwater basin. You've got to have stormwater separation. Got bunding around these tanks in case the tank bursts. There's a lot of redundancy in the plant. And this is the, after it's treated, we've got a plastic line storage, 30 megalitre plastic line storage, which is enough to store the entire treated water over the wet season, plus the rainfall that falls on it. You can sort of see the water that's in there is just rainfall at this point. And then that's irrigated out on the avocado and eucalypt woodlot over the drier periods of the year. So the approval process, we've got an operating licence from the ERA. We've got approval to construct wastewater appurtenance from the health department. It's not actually approved to operate yet. You have to actually commission it with live sewage. So until we've got enough houses producing live sewage, we can't commission it. So yes, you need to take a little bit of a leap of faith, but you're going to be able to get that through, no problems. It's registered under the EPA Act. It sits below a fully licensed EPA plant, but it is a registered plant, and we do have EPA conditions, and the conditions relate not so much to the sewage treatment itself, but to the treated water irrigation. And we've got approvals from the Shire and approvals from the Department of Planning. So 5 different government agencies were involved in the approval process, and there were times that it was quite frustrating because agencies wanted to see the other agencies' approvals first before they would give their approvals. But we eventually found a way where we could get through that and got things in place. This is the irrigation area, and you can see in the foreground here are avocados, and down here surrounding that's the you don't quite see the treated water storage in this photo, but you can sort of see the woodlot around it, which is irrigated woodlot. And we've got further land over on this side available for as the system grows to expand either our avocados, our woodlot, or even our vines. But our vines don't use that much water. They might only use water for a month or two in sort of January, February. So yeah, there would probably be more avocados or woodlot, depending on how they go. We initially looked at, because of the economics in avocados, they're sort of quite productive. We were initially looking at the full site being irrigated avocados, but I guess just to be conservative, eucalypt woodlots are really well proven for treated wastewater reuse in Western Australia and Australia. So we've got about a half-half mix there. So in the future, if the avocados also prove to be really successful, because avocados do use a lot of water and a lot of nutrient. In fact, the nutrient guidelines for what we're storing in the treated water dam, we're probably going to have to add in. We're going to have to add in nutrient back. So we're going to have to take the nutrient out to store it, and we'll probably have to add in some nutrient when we put it back on the avocados to make sure to have enough nutrient for our horticulture requirements. I guess. Yeah. So where are we now? Shelley, if you wanted to, we've got just a bit of a flyover, which can just run in the background. I'm just going to say a few things about, just to sort of sum up, and then we'll have some questions at the end. But if you wanted to put the flyover on either now or in a minute or so, you can do. And hopefully it's not too clunky. With the speeds on going through Zoom, but if it is, you can have a look. It's on YouTube under Witchcliffe Ecovillage. So we've got dozens of homes underway. It's been spurred on by the state and federal housing stimulus grants. So sales have been particularly strong. We already had, even before the grants were announced, we had a lot of people interested in living more sustainably on our database. We had huge interest in our first stages, but the housing stimulus packages have really spurred things on to happen very quickly. Our first residents have already moved in. Our landscaping is well underway. Our re-veg planting of the stormwater systems is in our first stages is complete. The oval has been fully turfed and is getting well established. Our village green has been, all the landscaping has been put in and is looking fantastic. Our street tree planting is underway in our main commercial areas, and our entry is all of our landscape trees, street trees are put in. We're still coming up to spring. We'll be looking at putting in our, we've got a lot of edible landscaping in our residential streets, so that'll be getting underway now. Our stormwater system proved itself really well in the first winter, and our first winter is probably the most difficult, given we had a huge level of builder activity. And we had that's not part of it. Okay. We also had a very wet winter, and also the first winter is where you have, I guess, the biggest challenges with establishment with sedimentation and erosion. So the first stage of construction was the largest residential construction project that there's ever, the Shire has ever sort of seen in the area. And we used one of the larger civil contractors in the state, Wormel, and they sort of had, it was a pretty large project, even in Perth scale for them. At one point, they had about 25 excavators trying to get the sewage and the stormwater system in place, going on site. So naturally there's been challenges with an innovative project and a project of this scale. But I just want to focus on a few, just to wrap up, focus on a few of the challenges that we've had from more from a water perspective. So protecting the downstream dams when constructing a really large scale earthwork project in a catchment with clay and silt soils during winter is really difficult. We had stormwater diversions. We had hay bale filters on every pit. We had a lot of hay bale filters along our waterways and for water coming into our waterways. And we still ended up with some turbidity in our dams. But fortunately, because our dams were so large and were able to capture all that water, we didn't have anything going out downstream, affecting the natural waterways or affecting the neighbours. Another one was testing the sewage system. The sewage system, a large sewage system with a lot of services going in. It's, even though you test each section with your air pressure, when it came to winter, because it's all been built in summer, when it came to winter, there were lids that were leaking, there were pipes that had been damaged. And so you need to be able to test your system as well as your standard water corporation type tests. And I guess the Water Corp has all this experience and knowledge, but we were doing this for the first time with a new operator. And so fortunately, we didn't have any sewage coming to the system. We were able to find those leaks and fix them before we started accepting any sewage. I've already said that about how the open swales operated really effectively. But we did have some erosion areas. We were expecting it, we stabilised them, and we full focus on making sure that vegetation is established and they won't be a problem in the future. Here's an interesting one, and it's it's not really directly our thing, but it's we're trying to help all of the lot purchasers to make sure they don't have issues. So there's been a couple of lot purchasers that didn't really think through the tank levels when they designed the house. And so your tank actually needs to be under your gutter level to be able to get water from your gutters into your tank. And they had it all looked great on the plan view, but with the topography of their lot, it created some challenges to actually install the tank and then to actually find an overflow from the tank. Because if you've got a big house or there's not anybody there for a while, or you've got a small tank, then while the tanks will capture a lot of the water coming off a lot and are really good for stormwater, they do still need to have an overflow built into them. So services are interesting. They're designed independently typically, and so I guess, but that's pretty much something, I guess, if you work in development, services is always a challenge, but fitting them in around the swales, I've mentioned before, like that was just something where allowing a bit of extra space in the verges makes that a bit easier. And of course, coordinating all those additional services in things such as microgrids, irrigation schemes, solar pumping, they all need a bit of extra coordination and management. And things like commissioning a solar pump system, it might be designed so you need all of your pumping predominantly in summer, which aligns well to when you've got good solar power generation. But when you're trying to commission it in the middle of winter, it wasn't very successful because we couldn't find enough sunny days. And then we had builders also starting to use the water during winter to get their just to get things started, and the system wasn't designed for that. So we had to work through a few things there. So we've completed 2/3 of the village. We've completed the most complex parts of the village. We've got the dams, we've got a commercial centre, we've got a new intersection from the highway, we've got a new sewage scheme up and running, a new wastewater treatment plant, extensive landscaping, microgrids, irrigation. We've got our causeway across our dam in, we've got buildings being demonstrated, and we've established a pattern for the remaining of civil works, and our approvals are now in place for the remaining 1/3 of development. And you should see construction starting on the final stages pretty soon. So thank you.
That's amazing, Wayne. Thank you so much for that presentation. We only have 2 minutes to go. So as everybody can see, it's highly complex and it's taken a lot of planning and a lot of negotiation. I think that's probably one of the key messages, is that there seems to be some straightforward approval processes, but they're quite complex. And just you mentioning, Wayne, that nobody wanted to give their approval before the other agency, that's actually a really, really difficult thing to address, particularly when this is a little bit new. So I recognize that we've only got 1 minute to go. There's a couple of questions up on the chat. So one is from Alison, and she said, "Hi, Wayne. You said there needs to be a certain number of sewage connections before the wastewater treatment plant can be commissioned. What happens with the sewage before it's commissioned?"
What we can do is actually treat it in batches. And also what happens is a lot of storage in the system. So there's storage in the pipes, the pump stations. There's actually inlet storage at the wastewater treatment plant. So we sort of fill up the storage, then we can treat it in a batch. And we've also designed the treatment plant so it's modular. So the little MBR unit that you saw when I had the picture on the screen, that was a 15 kilolitre a day unit. The ultimate plant will have four 40 kilolitre a day units. So we can start at a much, and that 15 kilolitre a day, that's its maximum. It can be run at a lot lower level. So we'll pretty much have enough people in that first phase of building to get that 15 kilolitre a day unit up and running. And we're bringing the 40 kilolitre a day units over straight away as soon as we can get them here from through the docks because we'll need to be getting them running straight away as well. So yes, it is a challenge, and particularly if you've got slow take up. What the fallback position is always to tanker it to like maybe another facility such as the Water Corporation facility, but that is very expensive. So we've done everything we can to avoid that and move straight into operational phase. And having a large treated water storage at the end, it also means we've got ability to put it into the storage, if we have any issues and it doesn't meet the quality requirements, which are part of our license, we can reprocess things.
Fantastic. That's great. Thank you. So if anybody has any questions they'd like to ask Wayne, please feel free to turn your camera on so that we can see you, and you can and then unmute and ask Wayne personally, or pop it in the chat. So there was only just one other question that came up a little bit earlier from Griff, but I think Griff has had to leave, unfortunately, which was about a little bit more about the flood storage and the system to manage that. So if you want to just explain that a little bit more. But as I say, anybody, please, if you show your face and come off mute, please feel free to ask Wayne a question or pop it in the chat, and we'll probably finish in the next minute or so.
Yeah, well, from the storage is pretty much more your 1 in 1, 1 in 5 type events, and that's just stored in your open swales. And you sort of saw those the crossings at the driveways, that kind of holds things back. You've got a lot of storage in your stormwater tank, in your rainwater tank, sorry. And even if the tank is full, there's still a lot of storage in a rainwater tank as the water level in the tank is increasing and the overflow starts. So right the way through the system, there's a lot of storage. The stormwater basins through all of the clusters, we've actually designed them to have sort of choked flows. So you might actually have a larger pipe coming into a stormwater basin and a smaller pipe going out. Sometimes the contractor thought, hang on, you've got things arse about here, but no, it's all deliberate so that we actually get sort of water being held in the basins. And we did have an example where we put mulch in one around the basin, and the water level rose up and the mulch blocked the pit lid, and the basin overflowed. But it's designed so the levels through the it's more about the ground level design, and we've modelled all the terrain and topography to make sure that even if the connections are blocked, there's sufficient capacity to flow overland. So the larger events, you know, your 1 in 20s, your 1 in 100s, they are all designed to flow down your roads, flow through the community gardens, following those the same paths as the waterways, but they will come up and inundate some of the surrounding land. But it's all been modelled to make sure that it's not going to inundate people's lots and people's houses.
Brilliant. That sounds fantastic. So if there's no further questions, and it doesn't appear to be, But if anybody wants to, just pop your camera on. But we're looking pretty good. Everyone's saying thank you. We are a little bit over time, but I just want to thank you again, Wayne, for such an incredible presentation. What a great project, and it is amazing to see this on the ground. So I hope that, and as Wayne mentioned, a lot of this information they want to share, the project wants to share it so that you don't have to go through these learnings all over again. So jump on the website and Google Witchcliffe Ecovillage, and there's a whole lot of reports that will help everybody else move through a similar process if we want to go there in the future, which I hope we do. So everybody, I know that you're all saying thank you, which is fantastic. Thanks so much for being in our New Waterways webinar for the day. Enjoy what sunshine we have, and we look forward to sharing some new waterways stuff with you again soon. So thanks, Wayne. Thanks, everybody. Have a great day.